Hi everyone, and welcome to this series of circuit practice problems. Now, in this question, we want to analyze this circuit using the principle of superposition. Before we solve the question, what is superposition? Superposition is basically, for example, here I want to find I0. So if basically I solve the circuit with all the three sources are there at the same time, we'll find I0. Then if you remove two of the sources and keep only one and repeat that three times, the impact of each source individually, because we are dealing with a linear circuit, can be added, and you will find I01, for example, only due to the 4.5 amp current source, and then I02 during the or because of the impact of the 20 amp, and finally due of the 50 volt source. If you add all these three currents, you will get the same I0. So the principle of superposition, this is basically because of the linearity of the circuit. So let's basically start solving this example here. We want to find I0. Okay, and we want to find I0 using the principle of superposition. So basically here, we remove two sources. Now, how to remove the sources? The current, we want to set the current equal to 0, so it's an open circuit. So I remove the 20 amp source here, and basically it becomes an open circuit. And I remove the voltage source by setting the voltage equal to 0, which means this is a short circuit. So now I want to find I01. Okay, so this is the current due only the 4.5 amps. And this is very simple circuit. This circuit can be really reduced to the current source, the 4.5 amps, the resistance of interest. Now, this is as a hint. Whenever you are using the principle of superposition, you can do any circuit modification you want, but don't touch the element of interest. So this is the element of interest. Do not include it in anything. Otherwise, you will lose the information required. You will lose the location of I01. And here we have here the three resistors. So we have here the 15 ohm, the 10 ohm, and the 14 ohm. Now I want to add all of these together as one resistance only. So the 1.8 here, so these three are in parallel, and the 1.8 is in series. So your R equivalent is equal to 1.8 plus 14 in parallel with 10 in parallel with 15. So this is equal to 1.8 plus 1 over 14 plus 1 over 10 plus 1 over 15, inverse of that to get the equivalent resistance, and this is approximately is equal to 6 ohm. So now my circuit will be the 12 ohm and the 6 ohm here, and this is basically your 4.5 amp. Now this is what I want to find, I01. Now the current will go basically and will be distributed in that direction. So I01 is in the negative direction of the current that will be entering the circuit, and using current division, so your I01 will equal to minus, because as I said, the current will be entering this way, opposing the current direction given in the question, times the main current 4.5 times current division, you multiply it by the other resistance in parallel, divide by 6 plus 12, and this will give you minus 1.5 amps. So that is basically your I01. Now, let's move now and find I02, and the circuit that I will have, basically, I remove the current source and the voltage source. Again, this will be an open circuit, so the current here, I, is equal to 0. So there will be no current. So the current here, basically, this is I02, and this is I02 as well, because the current will be going in that direction, and here will be no no current. Again, I will add these three resistors in parallel, basically. And so you will have here your R equivalent is equal to 1 over 14 plus 1 over 10 plus 1 over 15, inverse of that. And this basically will give me a total resistance of 4.2 ohms. So this is the total resistance that I will basically have it in this parallel configuration. So I will have here the 1.8, the 12 ohm, and this is your I02. This is my current source, the 20 amp. And in parallel with that, I will have the 4.2 ohm resistance. Now the current will go up and will split in this direction. So the current that goes in this branch is in the same direction of I02. And I will also use current division. So your I02 will equal to the main current 20 times the other resistance, which is basically 4.2 divided by 4.2 plus the total resistance here in series, which is the 13.8 ohm resistance, and this is approximately will give you 4.667 amps or 4.67 amps. Okay, so that is I02. So this is your I01 here, and this is your I02. Now we'll move to the last part here, and we will remove the two current sources. So this is an open circuit and this is an open circuit. So we'll have here a voltage source. Okay, now how to analyze this? One of the suggested ways is to use nodal. So if I use this as my reference, this will be my V. We have only V. Okay, and that's it. We have only one node here to be concerned with. So KCL at V, the node V. So currents are leaving. This current is leaving. So it is V minus 0 over 12 plus 1.8, which is 13.8, plus the current that goes down here, V over 14, plus the current that goes here, V minus 50. Now, why minus 50? Because the polarity is minus plus divided by 10 plus the last current is. We have here 4 branches, 1, 2, 3, 4. So we have to have 4 terms in our equation. V1 over 15 equal to 0. Sorry, V, no V1. It's the same voltage, all V. Okay, so we have one equation, one unknown, so we can solve it. So this is 0.0725 V plus 0.0714 V plus 0.1 V plus 0.0667 V equal to minus 5. This is plus 50 over 10. 5, take it to the other side, becomes minus 5. Solving for this, your V will be basically equal to 16 minus 16.1 volt. Minus 16 point. This is your basically your V. Now what I want is I03. I03 will equal to the node voltage, which is between this point and this point, which is the minus 16.1 divided by these two resistors in series, the 12 plus the 1.8, or the total of the 13.8, and this will give me minus 1.167 amps. So your total I0 equal to I01 plus I02 plus I03, and this will give me around 2 amp. This is how to deal with basically the superposition theory. So sometimes it's really very, very useful, especially when the circuit is complicated. Removing all these sources except one can sometimes really reduce the complexity of the analysis.